The title of this notes is Verifying Inverses. And the essential question is, what is the relationship between f and f inverse? So the first relationship we're going to talk about is when the inverse is a function. If f is what is called a one-to-one function, then f inverse is also a function. So this is a new vocabulary word, a one-to-one function, and you'll see it abbreviated one-to-one, 1-1, means a one-to-one function. So let's think about an arbitrary function. And I'm going to say that f has a couple of inputs. I'm going to put them into the boxes, into the circles. And here's the f function, and then here are my outputs, f of x. So I'm going to do a mapping. I'm going to say that my function machine takes the number 0 and sends it to the number 1. And then it takes the number 1 and sends it to the number 5. There's no pattern here. And then it's going to take the number 2 and send it to the number 1. F is a function because every single input has only one output. 0 only goes out to 1. Right here. The 0 doesn't turn into anything else. So then the inverse will go the other way. So one of the things you're going to have to do is, instead of a mapping, you'll see this as a list. It'll say the function f is defined as the points 0, 1. I'm taking this from 0 to 1. We also have the point 1, 5 and 2, 1. So function just has 3 points, and that's fine. If I were to graph them, it would pass the vertical line test. So the inverse is going to go the other way. So the inverse is going to take 1 and map it to 0. And then it's going to take 5 and map it to 1. And then it's going to take 1 and map it to 2. You'll have to do this on your test. All right, so what about the inverse function? Is that actually a function? Would it pass the vertical line test? Well, if we were to plot it, let me extend the page here. If we were to plot that f inverse on a graph, we would have the points 1, 0. We would have 5, 1. So 1, 2, 3, 4, 5, 1. And we would have the point 1, 2. Is that a function? It's going to fail the vertical line test. So this is not a function. And that's okay. Sometimes when we take a function and we take its inverse, the inverse is not a function. In that case, the original function that we were dealing with, this is an example of something that is not one-to-one. If our inverse did turn out to be a function, if it did pass a vertical line test, then we would say that f is one-to-one. So how can we tell? Well, we can tell from a graph really quickly if you're not a function, you fail the vertical line test. All right, so remember that an inverse is all about switching x and y. So instead of failing the vertical line test, we're going to think about the horizontal line test. So let me just put 2 functions up. Let's have one function be x squared, and let's have another function be 2x. Okay, so what does the graph of x squared look like? It's a parabola opening up at the origin. If I were to graph the inverse, remember doing that y equals x line? Notice that my inverse is not a function. In black, it's failing the vertical line test. Well, I could have tested the original function without graphing the inverse with a horizontal line test. Because it fails the horizontal line test, all that means is that f is not one-to-one. So let's look at a function that is one-to-one. Here we have y equals 2x. It's a line. It goes to the origin, has slope of 2. Okay. Is its inverse one-to-one? Sorry, is the function one-to-one? Well, does the function pass the horizontal line test? It does. It passes the horizontal line test, so f is one-to-one. What is the significance of that? Here is the line y equals x, and we're going to reflect the function over the line y equals x to see that the inverse looks like this in blue. Is the inverse a function? Absolutely, it passes the vertical line test. That's what being one-to-one means. If f is one-to-one, then the inverse is also a function. The next property of inverses I want to talk about is domain and range. So when you have inverses, all this says is that the domain and range switch, and we know that from our pictures. If we have, here's all my inputs, or my domain, here's all my outputs, or my range, f takes my domain, sends it to my range. F inverse goes the opposite direction, it takes my range, and sends it to my domain. So this is F inverse. The inputs of F inverse are the range of F. The outputs of F inverse are the domain of F. That's all that's saying, so that domain and range switch places. Okay, the most important property is this composition property. And you're going to have to use this composition property to verify inverses on your test. So this property says that if you do the composition f of f inverse of x, it will equal a single x. No other numbers, no other symbols. Likewise, if you do f inverse of f, so the order here doesn't matter, you'll still end up with x. So let's do a quick example here. So let's use that function we did on the last page. Let's call f 2x. So f of x equals 2x. So what is its inverse? This is practicing what we were doing last class. Change f of x to be y, and then switch your x and y, and then solve for your y. So y equals x over 2, and y is just f inverse of x. So the inverse is x over 2. So let's verify that we have the right answer. Let's calculate f of f inverse of x. So our outside function is f. So I'm going to write 2 blank, and my inside function is f inverse. So I'm going to write x over 2. And then I'm going to simplify. 2 times the denominator 2, those cancel out. Remember, this is the fraction 2 over 1 times 2 in a denominator, and it equals x. And then if I go the other direction, what is f inverse of f of x? Okay, well this time, the inverse is our outside function. So let's write the inverse with the blank. Blank divided by 2. And in the blank, we will put the inside function, f, which is now 2x. And then we simplify. That line there's the blank. So we have 2x divided by 2. 2 divided by 2 cancels out, and it equals x. Therefore, I have verified that x over 2 is the inverse of 2x, because the composition f of f inverse equals x. The last property is something that we explored last class. I'm not going to go over it. The graphs reflect over the line y equals x, and that's what we saw when we were doing our Patty's paper exploration. So this is the end of our notes. Go ahead and draw your line for your summary and bring your notes in for class.